Köszönöm. Hello everyone, so my name is Michal. I work in Kiwi.com in our Prague office. And I'm gonna tell you a little bit about serverless and backend stuff for JavaScript developers. First of all, I want to just quickly introduce Kiwi.com. So we are a flight ticket search engine and an online travel agency. And we do crazy stuff that backend hates, but people love. So you can search flights from Budapest basically anywhere, anytime, and we find the best deals all around the world. We also don't sell only flight tickets, but also combinations of flights and buses. So if you want to go from Budapest to Dresden, you fly to Prague. And if the flight is delayed and the bus departs without you, the biggest added value of Kiwi.com is the Kiwi.com guarantee, so we will get you to your final destination on our own. We are not any small startup. We do more than 8,000 bookings per day. We did some big turnover last year, and this year should be probably doubled. We have totally like 250 developers, and we have few offices around Europe. We are trying to do a lot for community. So as was said, we are doing this JS road tour. We are gonna have 8 talks in 8 countries during 2 weeks. So Budapest is currently just in the middle. It's getting a little bit too much, but we brought you some Czech beer, and we would like to talk more about anything you are interested while drinking the beer. So check out where we currently are on this website. And if you are interested in like getting more about JavaScript, we are planning to organize a weekend workshop in Brno. It's gonna be about all the cool technologies like GraphQL, React Native, Flow. You can also suggest topic that you are interested in. The URL is here. You have to complete some entry task because we are targeting on a little bit experienced developers, and we will pay the tickets, get you to Brno, and handle everything. So that's basically about Kiwi. And now to the topic of the talk. So backend for JavaScript developers, what's like gonna be about? We as a JavaScript developers, everyone here is JavaScript developers. Someone here is not a JavaScript developer. Wow. So it was used to be like this way. JavaScript developers are the front-end guys, and then there are back-end guys. Front-end guys deliver the UI, and then back-end guys have to deliver the API. But there are like things currently that front-end guys doesn't have to wait for back-end guys. We basically want to do some basic hosting, dynamic hosting. We maybe want to use some databases, do some browser in the cloud, and all these things are available and all you need is to know JavaScript. So static hosting. What I mean by static hosting? It's basically put some files online, get some, like, for example, sharing of your beta versions. Every merge request should be deployed somewhere. And it's ideal for single-page applications. I guess a lot of you is in this situation, so I suggest start using Now, which is simply installable through npm. You get the command, you type now your folder, and you receive some URL on now.sh. Of course, you can assign your custom URLs, but the idea is this hash. So every time you change something in your folder and you do new deployment, you receive a new URL, so you can easily switch back if something went wrong. And it's like great developer experience. It's basically for free. If you are in a need of having dynamic hosting because you need some server-side rendering or some API endpoints, the Now has also support for this through now.json, where you basically define what file with which Docker image should be built and deployed, and that's basically it. Now is being developed by a company called Zeit, and Zeit is also maintaining the Next.js framework. Is anybody here using Next.js? Only few, so I highly recommend using Next.js, and Next.js is like first-class support in and now, so you receive all the server-side rendering, and it's really like, pardon?
What is it, Next.js? What is it about?
Next.js is like a minimalistic framework that handles server-side rendering and other cool things like routing, and it's a JavaScript framework. Okay. So you can do everything you used to be or like standard way, like doing PHP or Python on the backend. You don't have to do that. You can use Next.js and handling backend and frontend with one code.
So the static, you mentioned the static images. For instance, if it's just, just the file structure has changed the previous slides, and you're generating a new hash, okay, for the statics, and you need to change manually code to fit to accomplish the new generated static hash.
Oh yeah, but you basically.
It's not too comfortable.
Then you should probably use some. Basically, how you use it in real is that you alias some of these random URLs to some proper URL. So you basically do the deploy and switch to the proper like human readable or SEO optimized URL. You know what I mean? And in the code, you are not using the absolute URLs, so it works. If I get your question correctly, you don't have to change the don't use absolute URLs in your code. That's the solution. Okay. So now .sh, if you are interested more, you will get information about other things that they are offering, which is scaling. You get logs. It has great integration into GitHub. So, as I mentioned, doing those stage deployments with pull requests are pretty cool, and they offer a free hosting of the static files, so you can easily start using it. And if you want to use for like proper backend with a dynamic hosting, you are just being charged. Previously, it was something like $14 per month. They currently, like last week, deployed new pricing. And it's like pay as you go. So again, with standard usage, you pay a few bucks per month, and that's it. So you are like free to start developing stuff and don't stress too much about the backend. But of course, maybe you want more. You want a database, you want some caching, you need a content delivery network, and basically more control over all the infrastructure. So in this case, I suggest using a serverless framework. Serverless framework is again like easy to install through npm. Then you get a command. You also get access to a big library of templates. So the bootstrapping of the project is simple. And then you just type serverless deploy, and again you receive some HTTPS URL, and like you are done. The serverless framework supports many cloud providers like AWS, Google Cloud, Azure, and few others. Based on that cloud provider, you are free to use any languages the cloud supports. So if you already have a group or team of backend developers, they also can start using serverless framework. And the big benefit of this approach is, since the beginning, your infrastructure is written in a code, because I will handle it in the next slide. And it's greatly extensible with the plugins. Also about the plugins, I will mention a few slides later. So what does the infrastructure as a code means? It's you just describe your infrastructure in a config file. You create a serverless YAML where you specify the provider, the functions you want to have being deployed, and the external resources of the cloud you choose. So how does it look like? You say with the provider section that you want to use AWS, some node of like specific version of node, which region you want to deploy. By the way, everyone is familiar with AWS. You know how like regions and stuff like this works. And here you specify the amount of memory you want to use on AWS Lambdas, which the Lambda is sort of container that executes your code. And you are being then charged based on the usage of the time and the memory. So don't forget to specify something reasonable, otherwise you are being charged too much sometimes. And then you define the functions. So in this simple example, we want to have some post request URL that creates the users. So you just say on events of the type HTTPS on this URL, call this function. And that's basically it. You specify your logic here, and if you are using those templates in the beginning, you already got some file set up, so it's pretty easy to understand where to write the logic. And then also you want maybe use some resources of the cloud provider. So in this case, you want to save the users in some table. On AWS, it's recommended to use very often the DynamoDB because it scales greatly with the serverless approach. And so again, in a code, you specify, I want to have a users table, some attributes, what's going to be searchable and stuff like that. And that's it. And by this, you are like creating your infrastructure by writing it. So you are not clicking anything in the UI and forgetting 2 months later, how did you do that? And since the beginning, you have the infrastructure as a code. When I was mentioning the events, that there are many types. So AWS supports, for example, also not only React based on the HTTPS requests, but also if you, for example, upload something to your S3 bucket, then you can run some serverless function. Very often you want to resize, for example, photo that was uploaded, or you want to handle some repetitive tasks, so you define the event type schedule, and you just define every 2 hours run some analyze function, and it just runs. You don't have to do anything else. Since you are familiar with AWS, you maybe know these other events that are available on this cloud provider. Worth to mention is, for example, now Alexa Smart Home, which is like a buzz these days. I want to mention it because it just like gives you the ability to start playing with something. You have a free weekend, you want to try doing something with Alexa, so with serverless and AWS, you are free to go and do the experiments. There are the plugins, which you can extend the default functions of serverless. So you don't have to always write a code, deploy, and debug on a cloud provider. You can use offline plugin to work offline. If you want to use some syntactic sugar with your JavaScript, you can incorporate the Webpack configuration you are used to with, so they don't like force you to use some like Node version 6 something and its syntax. You can have the DynamoDB locally. You can define CDN if you need it. And there is also a wonderful plugin for headless Chrome. So you can get an instance of Chrome in your JavaScript serverless function, and you can interact with the Chrome through, for example, Puppeteer, if you know. So whatever like you are used to, or you are able to do with the Chrome through console, or maybe you are a little bit familiar with the Cypress IO. So you can do this task in the cloud, again based on some events, which can be like, I created new merge request, so please check the web on this URL and let me know if there are any JavaScript errors. Am I downloading too many external resources? Whatever. And it's pretty handy. Or you want to generate screenshots or PDF files. This plugin is very handy and pretty universal. How are you going to use plugins? Again, you just specify them in your serverless YAML, and that's it. What are we using in Kiwi.com on the serverless approach? So we resize images. It's JavaScript backend service that just resizes images based on the URL. We got a currency converter. That's, for example, by the way, that's a Python code. And our first version of GraphQL server was written as a serverless application. Because when we started, the schema was pretty familiar. We had like backend services, and clients were communicating with REST APIs. And we, as a front-end developers, wanted to start using GraphQL for fetching data, but we didn't want to ask backend guys to implement the GraphQL for us, because first of all, we were not that sure how to even define the schema and if the GraphQL is even a good way to go. Of course, it is a great way to go. And then, most importantly, we didn't want to bother backend guys with our extra needs, because backend guys very often don't understand why should they like leave REST and start doing some GraphQL. So we went with this solution. We created the JavaScript GraphQL proxy. So clients were able to communicate with GraphQL. The proxy translates the GraphQL query into REST API calls. Nothing was necessary to be changed on the backend. And we, as a front-end developers, received the big value of GraphQL. And because we deployed it as serverless, we didn't have to do any DevOps, stress with scaling. Everything was handled by the serverless. Now, it's Kiwi.com GraphQL server is not serverless anymore, because with that amount of traffic we have on the GraphQL, it became a little bit pricey. So we are deploying it as a standard Docker images. But the benefit of this approach was the validation of the idea and the schema definition. So version 1 was serverless. Version 2, which is current, is standard Docker images. But the version 3 should be, finally, the backend guys should implement the GraphQL schema in their Python backend. And they will use the schema definition as a task description, basically. They don't have to reinvent everything. They just have to match the schema as it was defined. And the users will never notice anything was changed. They will just still be able to communicate with GraphQL. So that's how we used serverless. Few words about the pricing. So serverless framework is for free. It's an open source library. Then you have to pick up some cloud provider, and they have their pricing. So AWS charge very often like 100 milliseconds and the amount of RAM you used. With the normal usage, it's really a few bucks per month, and there is a very generous free tier, like 1 million requests per month. So if you are about to start doing something, do some experiments, and maybe you are a little bit scared that it's going to be popular, you don't have to be in the beginning. So you have big freedom of fantasy, whatever you want to implement. There are also a few pitfalls. So if you define like 2 huge resources and it's going to be used, the pricing can sometimes be bad surprise. So have it as a notice. When you are deploying something, define alarms, check that you are using responsible amount of memory, for example, but just don't take it as a blocker. Just think about it. There is a size limit of how big application you can upload to the serverless. It's currently 50 megabytes, which is quite a lot. So if you have a JavaScript or Node application that is bigger than 50 megabytes, maybe you should also think about a little refactoring. And also the AWS Lambdas have a response limit. So if you design some API response that is bigger than 6 megabytes, then Lambda will fail and you have to like return already compressed response and redefine the API gateway. So if you are returning some big responses, think about pagination or redesigning the API. Mobile devices definitely suffer by downloading 6 megabytes responses. And also the serverless can give you like illusion of multi-provider. It sounds a little bit easy to just rewrite the serverless YAML and you can migrate from AWS to Google Cloud, for example. Actually, it's not that easy. You very quickly get binded to the provider. You start using DynamoDB that's not available in the Google Cloud. So don't think that if you are using serverless, you can switch the cloud providers every week. And basically, again, I don't think that you will need to switch cloud providers very often, maybe like once or 2 times during like your lifetime. And yeah, there were pitfalls and there is a lot of benefits, of course. So the biggest one benefit is you have one full stack team. You are not a JavaScript front-end developer that ends with the browser and then you are waiting for backend guys. You can have one team handling all the parts of the development, which means you save a lot of time of communication. There is like great commitment of the team, engagement to the project, and also it gives you the freedom of experiment. So it's very easy to deliver something. Have something on production quickly is like huge benefit in a startup environment. It's also easy to scale, so if you quickly deliver something successful, you don't have to be afraid about being successful, that people will use your product. You can handle the scaling and think maybe about like some cutting costs later. And as I was already mentioning, the huge benefit is having your infrastructure as code. You are writing your code, your infrastructure as a code since the beginning. So you always get like proper definition. You can like create test stages, whatever. And with these benefits, I believe you can say goodbye to servers and start doing the stuff with JavaScript everywhere. Thanks. Any more questions? Some more questions? Everything was clear? Cool. Yes?
How do you handle database connections to databases like PostgreSQL and MySQL?
What do you mean? Like, how do I handle it? Just use some. You mean in a Node.js?
No, in a serverless environment that contains
Well, yeah, you have to think about those containers as a stateless. So you have always create a new connection when the function is being called. Is that?
too much overhead?
But if you are using the DynamoDB, it's only like few milliseconds. It's really not the blocker. And with this stateless approach, you are receiving the scalability. You don't have to think about the resources like I have only 50 connections and what am I gonna do if I have 51st request. You can you don't even think about it. If you have 1 request per day or 100 per second, the serverless handles it by default.
So basically you don't recommend using anything other than DynamoDB, right?
No, if you want to use Postgres, use Postgres, but then you have to think more about the scaling. DynamoDB is great fit to this. But you can use Redis, Postgres, whatever is available in AWS. But with DynamoDB, it's really simple. Thanks. So okay, no more questions. So some more.
If you are really using this in production in your own teams, have you reached the point where the JavaScript developers themselves are really editing these YAML files, or do you have some kind of YAML file editor expert ops guy who assists in this or something?
Yeah, we do have a DevOps team still, but in the beginning, when those guys want to try something, they write the serverless YAML, and once the idea is evaluated, they always can get some tips and tricks by more experienced guys. But on the other hand, it's not the rocket science. You can get a lot of examples, and basically, yeah, JavaScript developers can handle the serverless YAML pretty easily.
So if I understand correctly, then the DevOps team is more there for support?
Currently, our DevOps team has a lot of things to do, but they do like serverless. It saves them a lot of time, so they got the skills. I believe they also already created some supported scripts for generating the IAM roles. So you starting a new project, you generate the credentials. You don't have to go into UI again for some repetitive tasks. So yeah, they like it. Developers like it, so it's a great match.
Do I understand well that your dev environment and probably the QA environment is quite different from the production one? Or
like currently overall in Kiwi.com or with serverless?
Sorry?
You mean with serverless? Or like how our infrastructure is done?
Are you using these same tools in production? I guess you have a robust server capacity that the DevOps have to deal with. These experimental tools are mostly for the devs in the environment. Am I getting it wrong?
Well, it depends. Of course, the backend of Kiwi.com is written in Python and it's maintained by like standard backend teams with DevOps support. But more and more things are starting with a serverless approach, and then there is no difference in the environment. What we have since beginning is deployed to production. There doesn't have to be changed anything. Maybe just like what you could use in production differently is you don't deploy only to one region. You do multi-region deployments, which is again no problem with serverless framework. So that's just probably the difference, maybe, yeah. And DynamoDB is not that scaled and stuff like that, but that is just configuration. That's just difference about the numbers, but the structure, the architecture is still the same. Yes. Yeah.
Who actually runs or applies these YAML files? Is it done as a build step, or what actually does the work of like creating the infrastructure described in the YAML files?
Yeah, it's in continuous integration server can run it, of course. Yeah.
Does that mean that me as a random JavaScript developer basically through this has access to generate lots of infrastructure that could later cost money for the company?
Yes, but then it's more like responsibility of those DevOps guys to have alarms on the AWS that something is not insanely used without a warning. And since we are doing code reviews, so at least 2 guys has to check the file. It's not a blocker. So yeah, we are not worried that much. We are more like try something, fail fast, and this way. Thanks.